So up until this point, what we've been doing is, if I gave you a log, you started out by changing it to exponential. What we will use now, we knew that once it was in an exponential, if we had a common base, we could drop the base. Our new property is if log base a of x equals log base a of y, then x equals y, or vice versa. So in other words, if you have a log with the same base on each side, one log with a base on each side, you can drop that and just set the arguments equal to each other. From the other side, if we have this, we can add a log to each side as long as we do the same base. So let's say I ask you to solve this equation. 8 to the x power equals 21. Now, on the quiz, you would have just tried to get a common base, right? You would say 8 is 2 to the third power, but does that work with 21? No. So we need another option. What we can do is add a log to each side. Now, logs can be any base we want, any positive number. We will prefer, if you look on your calculator, there's an LOG button. That's log base 10. Yeah, get a calculator too. Sorry. And right below that, there is an LN button. LN means log base E. We want to use one of these two because they're the buttons that are available to us and we can click the answer. So we will add one of those to either side. If you just want the log base 10, you don't have to write the base. Anytime you see LOG written without a base, it's assumed to be 10 automatically. So we know with equations, as long as you do the same thing on each side, that's a legal move. Now, how does this benefit me? We can figure out what log 21 is. Think about properties of logs. What can we do with the x? Comes down to the front. So this is x times the log of 8 equals the log of 21. So now if you want x by itself, you would divide. That is the log 21 divided by the log of 8. So we'll go ahead and type this in and get a decimal. When you push that log button, it opens a parenthesis, so make sure you close it. So log 21 divided by log 8. And we should get 1.4641. Okay. Just like any others, we can always check these by plugging them back into the original. If I did 8 to the 1.4641 power, it's not exact because we rounded our answer, but it comes out to be 20.9997. So it's very, very close to 21. Is that one okay? I want to do, we're not going to do all of these. Let's do e to the x squared power equals 200. All right. Can we get a common base? No. We have two options here. We can do it the same as we did the last one, just adding that log. When I have a problem with e's, I prefer to add a natural log. It doesn't matter. You can get the answer either way. It's just this is sometimes a little bit nicer. If we think about the properties of logs, that x squared would come down in front. the natural log of e. Natural log is log base e. That's like saying e to what power equals e? 1. Anytime the base and the log are the same, they really just cancel out. So that's why I prefer using the natural log here, just because I can drop that natural log of e. Now, if you use the log base 10, it's not a big deal. You'll just divide by log of e. If you didn't catch that, it's no big deal. You just divide it over. You're going to get the same answer. It just is a little bit cleaner along the way if we recognize it. Then what would you have to do to get x by itself? And when you square root, you need? So we have plus and minus the square root of the natural log of 200. We get 2.3018. So far, so good? Okay, so for our exponentials, before we could just drop the base, we had to have only one on each side. Before I can just add my logs, I need just one thing on each side. So on the left, what can I do first? If you're multiplying these, you add your exponents together. So 2x plus 1 plus negative 4x would be negative 2x plus 1. Okay, now if it weren't for this 3, we could get a common base on each side. Because of that 3, we can't. Only if it had a log there already. So we have to add logs. Which log should we use here? The natural log. Okay, the nice thing about that natural log, because it's a natural log of an e, you can keep that if you want, or you could recognize the natural log and an e would just cancel each other. But over here, because of that 3, we can't cancel. We just have to keep it, the natural log of 3e. Then what do we need to do to get x by itself? Subtract our 1. And then we will divide by negative 2. Now, when you put this in, you need to be careful, because the top of my fraction is 2 terms. You need to add an extra set of parentheses around the entire numerator. So we have parentheses, natural log 3e. The e button, you have 2 different options. Let me pull up my calculator. So we have parentheses, natural log 3. One place you can get an e is if you hit second and the natural log button. It brings up an e, but it requires you to put an exponent there. What exponent would I put? Just a 1, so you could do it that way. The other option is above the division sign. So if you hit second and the divided by, it brings up just the plain e. So you can use either one. If you do the first, it requires you to put in that first power. This one does not. And you can close your parenthesis minus 1, then close the parenthesis for the top of the fraction, divided by negative 2. So we get negative 0.5493. Okay. Let's do let's do this one. Is the common base an option? No. It's good to check. I will periodically put some in where you still can get a common base. It doesn't mean you'll get the wrong answer if you do all this. It's just a lot more work. It's a lot faster if we can get a common base. But we can't, so what do I need to do? Add log. You can do either one. The base isn't going to cancel here. So whether you prefer the natural log or log base 10, you get the same answer either way, so it won't matter. Then my exponent comes down. So then we have to divide by a negative log 8. So we get negative 0.0877. I think I'm going to stop here for today. So we just